Welcome back to class 10. We will talk about organic chemistry today. We will start with a new chapter, that is organic chemistry. So without wasting time, I just want to continue with it. Okay. Now what is organic chemistry? Organic chemistry is a branch of chemistry which deals with carbon and its compound, the specific compounds, not all, specific compounds of carbon, especially related with hydrogen. So carbon and hydrogen. So a compound formed by carbon and hydrogen is called hydrocarbon. Okay. So hydrocarbon are organic compounds composed of carbon and hydrogen only. So these are called hydrocarbons. So we will talk about hydrocarbons today, or organic chemistry. So natural sources of organic compounds, they are plants as well as animals, and we'll come to the unique nature of carbon. Since we are talking about carbon, we will talk about the unique nature. This is very, very important for you to understand our organic chemistry. We'll start with the property of carbon. So carbon, of course, is a non-metal with the symbol C and the atomic number. What is the atomic number of carbon? The atomic number of carbon is 6. So what would be the electronic configuration? So in the first shell, we will have 2 electrons. In the first shell, we will have 2 electrons, and in the second and the last shell, we have 4 electrons. So we call it tetravalency of carbon. So carbon, the valency is 4 because it needs 4 more electrons to have a stable electronic configuration. So carbon is tetravalent. So when we talk about the last shell of the carbon, so this is the nucleus of carbon. In the first shell, we will have 2 electrons. 2 electrons in the first shell. This is the nucleus of carbon. This is the nucleus of carbon, and we have in the first shell we'll have 2 electrons. In the second or the last, we'll have 4 electrons. So we call it since it needs 4 more electrons to have a stable electronic configuration, we call it is tetravalent. Okay. So this is the unique nature of carbon atom. So carbon forms 4 covalent bonds with mutually sharing 4 electrons with other atoms, and carbon is hence tetravalent and exhibits tetravalency, since carbon has 4 electrons in the outermost shell. So therefore it will show tetravalency and forms 4 single covalent bonds with other elements. Especially, let's say when we talk about hydrocarbon, it forms 4 covalent single bonds with a single atom of carbon will form 4 different single bonds with hydrogen. We'll come to that later. Now, we talk about catenation. What is catenation? Catenation is the tendency of an element to form a long chain of identical atoms. So, catenation is the tendency of an element to form chains of identical atoms, and catenation is maximum in carbon. Catenation is maximum in carbon. Okay. So catenation is maximum in carbon. Why? Because the value of carbon-carbon bond energy is maximum. So carbon-carbon forms a single bond over here, and this is maximum. So therefore this carbon undergoes self-linking and forms straight, branched and closed structure. So excuse me. So it forms a long chain of identical atoms. Long chain of identical atoms, or it will form a branched chain. This is called a branched chain. This is the single chain, and this is called the branch chain. And we'll have a cyclic also. Okay, somewhat like this: carbon here, carbon here, carbon here, carbon here, and so on. So we'll have a cyclic form of cyclic bond here, like this, somewhat like this. So it forms a cyclic bond. This is called a cyclic bond. Okay. So it forms as I told you, it forms a long chain structure. It forms a branch chain and closed chain structure. Now we'll come straight to different types of hydrocarbons. Okay, we will talk about the basic 3 types of hydrocarbons. The basic 3 types of hydrocarbons are, when we talk about hydrocarbon, there are 3 basic types of hydrocarbon. The first series is alkanes. We talk about alkanes, we talk about alkanes, alkenes and alkynes. And now, hydrocarbon, alkane, alkene and alkyne. Now, alkanes will have carbon-carbon single bond. Carbon-carbon single bond. Okay? Alkenes will have double bond between one pair of carbon atoms, and alkyne will have 3 single bonds. 3 single bonds. All right? Of carbon atoms. So therefore, this is alkane, this is alkene, this is alkyne. All right. Now, let us talk about the general formula of alkenes. CnH2n. This is the general formula of alkene. Okay, this is the general formula, CnH2n plus 2. When we talk about the general formula of alkenes. In another form of hydrocarbons, that is alkene, the general formula is CnH2n. CnH2n. And the general formula of alkyne will be CnH2n minus 2. So these are the general formulas of formulae of alkanes. This is the alkenes. Please remember, got to remember this. And this is, and CnH2n minus 2 is the general formula of alkyne. Alkenes, alkenes and alkynes. Now first we will talk about the alkanes only. We will focus on alkanes now. So when we talk about the simple hydrocarbons, the main thing that you have to remember is you have to look at the number of the name of alkanes, alkenes and alkynes or any other hydrocarbon will be given by the number, depending upon the number of carbon atoms. Remember. So if a compound has only one carbon atom, it has only one carbon atom, then we call it one carbon, then the it is known as meth or meth. If it has 2 carbons, then eth. Then if it has 3 carbons, then prop. Okay? Meth, eth, prop. 4 carbon. Then we'll have meth, eth, prop, bute. It's not but, it is bute. Okay? If it has 5 carbons, if a compound has, hydrocarbon has 5 carbons, then we will call it meth, eth, prop, bute, pent, and so on. Meth, eth, prop, bute, pent, 5. Number 6, meth, eth, prop, bute, pent, hexane, heptane, octane, nonane, decane, and so on. It goes on and on and on, but we are interested till pent. Okay? So if a hydrocarbon has only one carbon, that is called meth. The root word is meth. If it has 2 carbons, the root word will be eth. If it has 3, then prop. If it is 4, then but. And if it is 5, then pent. And then hexa, septa, octa, nona, deca, and so on. And alkanes, the IUPAC name, we use ane. Alkanes, A-N-E, ane. So if a hydrocarbon has 1 carbon, if a hydrocarbon has 1 carbon, it is known as meth. And then if it has a single bond, like for example, over here it has a single bond, so it is known as meth, alkane, A-N-E, ane. So meth, ane. Okay. Now, obviously, there are, I'll give you the structure of methane first. Why methane? I'll tell you afterwards. So I'll give you first to deal with the structure of methane. Now, carbon, we are interested in the outermost shell. We are interested in the outermost shell. Now, what happens is, in the outermost shell, there are, in carbon atom, in the outermost shell, there are how many electrons? 4 electrons. Okay, because it is tetravalent. It has 4 electrons in the outermost shell. So in one electron is shared with 1 hydrogen. Of course, since it is a hydrocarbon, it has to share with hydrogen. So 1 hydrogen comes and shares its electron with the 1 electron of carbon. Here, another hydrogen will come and share its only electron with one of the carbon electron. And again, another hydrogen atom will come and shares its electron with one of the electron of carbon. And then another hydrogen will come and shares its only electron with the only leftover electron of carbon. Now, carbon will have how many electrons now? 1, 2, 3, 4, 5, 6, 7, 8. So it forms a stable electronic configuration. Since it needed 4 electrons to form a stable electronic configuration for carbon, so carbon is tetravalent, as we can say. So, and it forms 4 single bonds with hydrogen. So instead of this, we can write the formula and the structural formula as, it forms a single bond here, single bond here, single bond here, single bond here with hydrogen. So therefore, this is a hydrocarbon with a single bond, which is known as alkane. So it's an alkane. So since it has 1 carbon atom, so therefore it is meth. And since it has a single bond, ane. So meth, ane. So hence this is methane gas. This is the structure of methane gas. This is the structural formula. And what is the structural molecular formula? CH4. CH4 is methane. Is it okay? Now we come to ethane. When we talk about ethane, the structure of ethane now. What happens is, eth means 2 carbon atoms. Eth means 2 carbon atoms. So ethane, carbon, single bond, carbon. So since it has 2 carbon atoms, so it will have 2 carbon atoms like this. Now since it is alkane, so carbon, single bond. So there is a single bond between carbon and carbon. Okay. Now what happens is, how many electrons are free? How many valencies? So there were 4 electrons in each carbon atom. There is a linkage. There is a link between a single bond between carbon and carbon. So therefore, since it is alkane, so we'll have a single bond. Now, how many electrons are free in each of the carbon atoms? There are 3 electrons here, free in each of the carbon atoms. So what comes here? Hydrogen, 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 one hydrogen here, another hydrogen here, and another hydrogen here. So the formula will be C2H6. The chemical formula of ethane will be, this is eth. Why? Because it has two carbon atoms. Ane. Why? Because it is an alkane. So A-N-E. A-N-E, alkane. So eth. Why? Because two carbon atoms. Ane. Why? Because there is a single bond between carbon atoms. So this is ethane. And the molecular formula is C2H6. Now, what is the general formula? You can have a look over here. I will give you an example of using the general formula here of ethane. You can use the formula to derive the formula of ethane also. The general formula is CnH2n plus 2. Now you must be wondering what N is. N is the number of carbon atoms. N signifies the number of carbon atoms. Please remember. So when we talk about ethane, eth means two carbon atoms. Okay. So instead of N we write 2. H2. Now N. 2N means 2 into N. N over here means 2. So 2 into 2. Why? Because number N means the number of carbon atoms. Since it is eth, we have 2 carbons. And then 2 over here. And then into 2 means 2 over here signifies the N. That is the number of carbon atoms plus 2 as the formula goes. So C2H. Now how many H's? How many hydrogen now? 2 2s are 4 plus 2, 6. So thus the formula Cn, using the general formula CnH2n plus 2 for alkanes, this is ethane. So it all depends upon the number of carbon atoms, because N signifies the number of carbon atoms in the hydrocarbon. Okay. Now the next is methane. We have done ethane. We have done. Now we come to propane. Now prop means how many carbon atoms? As we all know, prop means 3 carbon atoms. So three carbon atoms. Okay. Prop means 3 carbon atoms. Now obviously we're talking about alkanes here. So therefore we have a single bond between them. Single bond between them. Is it okay? Next. Over here in this carbon there are 4 electrons, and 1 electron forms a single bond with another electron of this carbon. So how many hydrogen valencies still unused? How many electrons still left? 3. Is it? Similarly here, one electron is used up in forming a single covalent bond with carbon. So therefore how many electrons free? 3. Over here, how many electrons here? 1 electron forms a covalent bond with 1 carbon atom. This 1 electron of this carbon, the central carbon, will form another bond with, so it's engaged. So how many free? Only 2 free, because 2 carbon atoms are used here. Sorry, 2 electrons of carbon of the central carbon over here, the carbon which is in the middle. 2 electrons are being used in forming single covalent bond with each other. Now the electrons, how many free? 2. So therefore 1 hydrogen comes in, another hydrogen comes in here, one forms a single bond, another hydrogen forms a single bond. Since it's a hydrocarbon, it has to form between carbon and hydrogen only. So therefore hydrogen comes in, and hydrogen comes in. So this is the structural formula of propane. Propane. Prop means 3 carbon atoms. Ane means alkane, having a single bond. So thus this is the structure of propane, and the general molecular formula will be C3H. You can have a look. You can count it. It's 8. 1, 2, 3, 4, 5, 6, 7, 8. So C3H8. All right. So similarly, we go to butane. Structure of bute. Bute means how many carbons? 3. 3 was prop. Now bute means 4. And since it is ane, alkane, single bond in all the carbons. Okay, single bonds. Now, similarly, how many electrons are free here? 3 here, 2 here, 2 and here 3. So therefore, one hydrogen comes in here, another hydrogen, 2 hydrogens in this carbon, in this also 2, and here 3 hydrogen comes in. So therefore, the formula C4H10, C4H10, that is the molecular formula. This is the structural formula. So this is butane. And so on, we can carry on with pentane having 5 carbon atoms. So that was alkanes for you. Methane, ethane, propane, and you can do your butane, and then you can try yourself the pentane. That's not a problem. Now we come to alkenes. And by the way, alkanes, that was the methane, ethane, propane, butane, pentane. These are the IUPAC name. IUPAC means International Union of Pure and Applied Chemistry. That is the full form of IUPAC. So IUPAC name. Okay. Now we come to the trivial name. So it will have IUPAC name and it will have a trivial name. So IUPAC name is methane, ethane, ethane, propane, butane, pentane. Now we come to the trivial name or the common name. It is the same. For alkanes, the IUPAC name and the common name is the same. So methane, propane, ethane, butane, pentane, and so on. So IUPAC name and the trivial name or the common name is the same, but not so in the case of alkenes. Now alkenes, as we can see here, 2 double bonds are formed between carbon atoms. So minimum carbon atoms we must have in the alkene group is 2. So we cannot have methane because meth means only 1 carbon atom. So we cannot have methane. We cannot have this methane now. Okay. Why? Because minimum we must have a double bond between carbon atoms, and then there has to be minimum 2 carbon atoms for alkenes to exist. So therefore, we will start with ethene. Alkenes starts with ethene. It starts with ethene. Eth means 2 carbons. Ene means alkene group having carbon-carbon double bond. So carbon-carbon double bond here, eth. So we have a carbon-carbon. Eth means 2 carbons. Ene means double carbon-carbon double bond. So we will have carbon-carbon double bond. Now as we know that each carbon will have 4 electrons in the valence shell. So therefore 2 electrons are engaged here. 2 electrons of this carbon is engaged here. So we have 2 electrons each in each of the carbon atoms. And what comes in here? It forms a single bond with hydrogen. So therefore C2H4. So we can use the general formula to get the molecular formula. CnH2n. That's the general formula for alkenes. Over here we are talking about ethene. So eth means carbon atom. N means symbolizes the number of carbon atoms, 2. H2n means 2 into 2. So therefore C2H2 to the 4. So C2H4 is the general formula of ethene. So C2H1, 2, 3, 4. So I hope you got the idea of the formula of ethene. Now we comes to propene. We'll come to propene. Prop, 3 carbon. Prop means 3 carbon atoms, as you can see. So 3, 1, 2, 3. So we'll have ene means now alkene group, so double bond. All right. Now we cannot have double bonds in all the carbon atoms. In one pair only we'll have carbon atoms. So double bond, sorry. So double bond in the first pair of carbon atom and then single here, bond here. Is it okay? So now over here, how many electrons are engaged in this? Only one electron in the case of this third carbon atom. 1, 2, 3. 3 hydrogens here. Because 3 electrons are free. Because one electron is forming a single bond with this carbon atom. So therefore, one electron is engaged and 3 electrons are free. So in the 3 hydrogens will come and forms a single bond with this carbon atom. Now, what about here? In this case, we'll have 2 electrons are engaged this side and we have 2 electrons free. So we'll have one hydrogen here. And what about how many hydrogens here then? So if one electron is engaged this side and 2 electrons are engaged this side, so forming a single bond with carbon on either side. So therefore, only one electron is free. So therefore, it forms a single covalent bond with hydrogen. Maybe on the top or lower, doesn't matter. So C3H6 will be your will be your molecular formula of propene. So C3H6, all right, using the formula CnH2. And similarly, we can go on to butene. We can go on to butene now. Have a look. So when we talk about 4 carbon atoms, B-U-T-E-N-E, but means 4 carbon atoms, and ene means alkene group having carbon-carbon in one pair of carbon-carbon double bond. So but 1, 2, 3 and 4. So we just suppose that we have double bond in the first pair of carbon atom and single bonds here. So we'll have one hydrogen here. Similarly, as I have explained earlier, Y2 and 3 and 1 hydrogen I have already explained. So we can check it out yourself. Yeah, and we have only one carbon here, one hydrogen here. So therefore, the formula for butene will be C4H 1, 2, 3, 4, 5, 6, 7, 8. C4H8. C4H8 will be a molecular formula of butene. This is 1 butene. This is normal butene or 1 butene. Why? Because we have the carbon double bond in the first pair of carbon atoms. Now, if we have double bond in the second pair of carbon atoms, then this will be known as 2-butene. This will be known as 2-butene here. Okay, this will be 2-butene. Why? Because it has double bonds here. So C4H8 will be a formula for butene, and this will be a molecular formula for 1-butene also, 2-butene also. So since the molecular formula is same and the structural formula is different, they are called isomers. The new term, isomer. Or isomerism. It shows isomerism, or these are isomers. Butene, 1-butene and 2-butene, having different structural formula but the same molecular formula for 1-butene and 2-butene. There are other compounds as well. We'll talk about it later. So that was alkenes for you. Now the last part we will do is alkyne group. The last part we will talk about is alkyne group. So similarly, alkyne means having triple bond between carbon atoms, Okay. So since it needs minimum 2 carbon atoms, so we cannot have Similarly, we cannot, like the alkenes, we cannot have methane, we cannot have methane either. Okay, because minimum number of carbon atoms needed for the triple bond is 2. So we cannot have because methane means only having one hydrocarbon having only one carbon. So therefore, we start with ethane. Oh, sorry, I forgot to tell you the common names. You can check out at page number 226 in your textbook. There are common names. You have to learn it by heart. We cannot derive the common name. You can name anything, isn't it? It's because it's a common name. So common name does not have any scientific reason or way of naming things. So therefore, ethene is known as ethylene. Propane is known as propylene, Ylene. Butylene, and so common name over here, alkenes, Ylene. Ethylene, propylene, butylene, pentylene. This is the common name. Okay, we just have to add this Ylene to the root word. Ethylene, propylene, butylene, pentylene, and so on. So these are the common names for the alkenes. Depending upon the number of carbon atoms, you just have to add Ylene to the root word eth, prop, but, pent. Simple. So now we come to alkyne group. We'll come to alkyne group. So, to the alkyne group now, similarly, we'll have ethylene or ethane having carbon-carbon triple bond. So, eth means two carbon bonds, two carbon atoms, and ylene means, eth means 2, and kyne group, Yne. So, ethane, this is ETH, 2 carbon atoms, Yne, triple bond. Ethane, so this is ethane, having 3 carbon bonds, having 3 triple bonds, carbon-carbon triple bonds, 3 carbon-carbon triple bonds. Now, you know that carbon atoms, there are 4 electrons in the outermost shell. So 3 in each of both the carbon atoms are engaged in forming, 3 electrons are engaged in both the cases, 3 electrons are engaged in forming triple bonds. So therefore only 1 electron is free in each of the case, in each of the carbon atoms. So therefore 1 hydrogen comes in here, 1 hydrogen forms a single bond with this carbon. So C2H2 is the molecular formula of ethane, and its common name is ethylene. For ethane is acetylene. Okay, so you must have heard about acetylene gas, which is used in welding. Okay, acetylene, C2H2. Now we come to the next one, that is propylene or propane. We'll talk about propane now. We'll talk about propane, P-R-O-P, prop, Y-N-E, propane or propene. So propane is how many carbon atoms? 3. So we'll have a triple bond here. Similarly, we'll have 3 carbons, no hydrogen here, because all the 3 carbon atom, the electrons of this carbon, this particular carbon in the center, all the 4 electrons are engaged in forming single covalent bond this side and 3 triple covalent bonds this side. So no electron free. So this carbon will not have any hydrogen attached to it. So here in this carbon atom, there are 3 electrons engaged in forming a covalent bond with another carbon. So it has only 1 electron free. So 1 hydrogen comes in here. Is it okay? So therefore, the formula would be C3H4. C3H4. This is propane. And the the common name of propane would be methyl acetylene. It is known as methyl acetylene. All right. Next is propane over. Now we come to bute. Bute. So butene will have 4 carbon atoms. So the triple bond in the first pair with single bond here. Similarly, we will have 3 hydrogens here attached to it. Single bond with single bond. 2 hydrogens this side in this carbon. No hydrogen because no electron is free now. Only 1 electron free, so 1 bond here. So therefore, the molecular formula will be C3H12345 So C3H6, and its common name would be ethyl acetylene. It will be ethyl acetylene. Now, the second type of the butane. This is the first 1-butane. This is 1-butane. Now, if you have a triple bond here in the second pair of carbon atoms instead of the first one here, as I'm erasing it, you can have a look. We will not have any hydrogen attached to this carbon because all the 4 atoms of carbon forms a single bond. This is 3 single bonds this side, 1 bond this side. And this similarly here also, for this carbon, 3 electrons are engaged in forming a single covalent bond with this carbon, and 1 electron here forms a single bond. So no electron left free here. So over here, now it will have 3 electrons left. So therefore, 3 hydrogen. Okay. So this is, since the triple bond is in the second pair of carbon atoms, in the second carbon, so therefore we call it 2-butane. 2-butane. So this is called dimethyl acetylene. So dimethyl acetylene is the common name for 2-butane. So the 1-butane and 2-butane, the structural formula is different, but we have the same chemical, the molecular formula C3H6. So it is also a very good example of isomerism, or we call it isomers. So we will end the class today with this. So in the next class, we will talk about the alcohols, the aldehydes, and the other functional groups. Okay? So thank you for watching. I hope you understood.